Okay, so we have the Incredible Hulk, who will basically just be a stand-in for me. Is in a tug of war match with Baby Leroy. Baby Leroy will basically, we're just using that to symbolize everybody else. Assume both of them keep a firm grip on the rope. The rope doesn't slide in either person's hand, and that rope is very light. At time t equals 0, both are at rest and the match begins. Obviously, the Hulk wins. 4 students try to explain why the Hulk wins the tug of war. Hulk wins because the leftward force on Hulk is less than the rightward force. Hulk wins because the leftward force on Hulk is less than the rightward force on Leroy. Hulk wins because the leftward force on Leroy is less than the rightward force on Leroy. Hulk wins because the leftward external force on the Hulk-Leroy system is less than the rightward external force on the Hulk-Leroy system. Woo! All right. Draw a free body diagram showing the forces acting on the Hulk and Baby Leroy, and then the external forces on the whole Leroy-Hulk system. All right, so starting with Baby Leroy, we have a downward weight, which is going to be so tiny, because he's so tiny. But that doesn't matter in tug of war too much. I mean, it does, but indirectly. So we have the normal force, which is the earth on Baby Leroy pushing up. And then we have the weight force, mg, which is Baby Leroy pushing on the earth. Push, opposite directions, right? Agent, object, all of that. And then we have this giant pull to the right, which we are going to call tension from the Hulk on Leroy, pulling Baby Leroy this way. And then we have this one more little arrow, which is hard to see, but it's exactly one box in length. And that is our frictional force. That is the ground pushing on Leroy. Okay. Forces on the Hulk. Well, we have a much bigger mass. So that means we have a much bigger normal force. Which also means we have Ft, which is the Baby Leroy on Hulk. And then we have a greater frictional force. We have a greater frictional force because, remember, our frictional force is basically coefficient of friction times the normal force. And if we increase our mass, then we're increasing our normal force. If we increase the normal force, we increase the frictional force. So there we go. Everything here adds up to 0, and everything here adds up to Baby going right. I don't know. I don't know if I have the camera flipped or not this time. External forces acting on the whole system combined. We have 2 downwards. We have mg, little mg, and then we have the bigger mg. For you on your papers, I know I'm being kind of sloppy, so that way you can see this, but hopefully if you only used one box right here to go down for the Baby Leroy's mass times acceleration due to gravity, you would only use one box right here. It has to be consistent. And speaking of which, why am I going to tell you? Why can't I just practice it, right? I can use different colors, so that way you can see what's happening. Because Baby Leroy is one box down over here, then we have to have one box down. So we'll use green for Baby Leroy's forces, and then we have Hulk, capital MG. Earth on Hulk, Hulk on Earth, normal force, normal force. All right. And then we're going to have force of tension on the whole thing, and we're going to have force of friction on the whole thing. Is the system moving? Is the middle of this system moving? So we know the middle of the system is going to be closer to Hulk, right? So most of the system isn't going to move, but some of it will, and it's going to move to the right. So this is the frictional force of the ground on Hulk, right? Because if Hulk were going to the left, then frictional force is going to go to the right. And then we have the frictional force on the baby. See what I mean? It's just kind of a jumbled mess. Make it neat. Clean it up. Make yours better. The baby would go to the right, so frictional force should be to the left. All right, onward, because this is taking forever. All right, Mark, next to each student who made a correct statement with no, we're just going to go through this. Boom, boom, boom. So we have student 2 is not correct. They made a correct statement, but incorrect statements. Wait, what? Hulk wins. True, because the leftward force on Hulk is less than the rightward force on Leroy. No. The tension force on Hulk equals the tension force on baby. This is an action-reaction pair. So the rope, one tension, has to be equal all the way throughout it. If you'll notice on our free body diagrams, it goes all the way to the right. That's our tension. Then the second one goes all the way to the right. Tension is the same in the rope. The only thing that's different is the amount of friction. All right, and then finally for D, the student who gave correct statements still did not give a complete explanation why. Synthesize the correct statements into a single, complete, paragraph-long explanation of why the Hulk wins the match. A complete explanation will include discussion of specific forces on specific objects of the system and citation of specific physical principles. Give me a second, I'm going to type all that up, and it'll be magic. So I quickly put the Hulk wins because the Hulk has a greater frictional force to the right than baby has to the left. So the Hulk-Leroy system together accelerate to the right. That's it. Do more practice problems. Get down Newton's third law.